Derivatives of inverse trigonometric functions. We're going to combine two ideas today: implicit differentiation, where you take the derivative of both sides of the equation, and inverse trigonometric functions, which we've been working with for the last couple of days. So let's start with the derivative of the inverse sine of x. Often, when we don't know a derivative and we look at it for the first time, we do the limit as h approaches 0, f of x plus h, minus f of x all over h. But we don't really know much about this function whatsoever. So we're not going to work with the definition. Instead, what we're going to do is take the derivative by first taking the sine of both sides of the equation. So the sine of y and the sine of the inverse sine of x. The reason we're doing that, the sine of the inverse sine will just leave you with x. Why does that happen? These are inverse functions of each other. They undo each other, so you're left with what you started with. You can draw a picture for that. The angle is y. Let's put that in the corner. Sine is x over 1. Sine is opposite over hypotenuse. And then you can find the missing side using Pythagoras. We'll use this later. Let's now take the derivative of both sides of this equation. We're going to take the derivative with respect to y. So the derivative with respect to y of sine y will be cosine y times dy dx, and the derivative of x is just 1. So let's do that again. Derivative of sine is cosine, leave the angle alone, multiply by the derivative of the angle, and the derivative of y is dy dx. Derivative of x you're very comfortable with. The answer for that is 1. Our aim is to get dy dx by itself because dy dx just means derivative. So we'll divide both sides by cosine y. If we only knew what cosine y was, we could put this back in terms of x, which is what we started with. So we'll look at the picture now. Cosine of y, adjacent over hypotenuse. So the cosine of y is the square root of 1 minus x squared. And we can put this instead of y, of cosine y. And there's a lovely answer for the derivative of the inverse sine of x. It's in terms of x instead of y, which is always better because we started with x, we want to end with x. So just a quick recap of what we did. We took the sine of both sides. That gave us an equation that we're much more familiar with. We know the derivative of sine, so we can just take the derivative of both sides of the equation. Derivative of sine y, cosine y times derivative of angle. Derivative of y is dy dx. You're solving for dy dx, get it by itself. Look at the triangle to fill in for cosine y, and there's our answer. Let's try the derivative of the inverse cosine of x. To get rid of the inverse cosine of x, we'll take the cosine of both sides. The cosine of the inverse cosine of x will be x, and we can draw a picture for that. Our angle is y, we'll put that in the corner. Cosine adjacent over hypotenuse. Hypotenuse is assumed to be 1 because x is over 1, and we find the missing side using Pythagoras. We can now take the derivative. Derivative of cosine is negative sine angle times derivative of angle, and derivative of x is just 1. We'll do that again. Derivative of cosine of angle, negative sine angle, derivative of angle, dy dx. Derivative of x is just 1, and our goal is to get dy dx by itself. So we'll divide both sides by sine minus sine y, and we tend to put the negative on the top instead of the bottom because we're more accustomed to that, and it's easier to find common denominators if we want to work with this. So we divide it by minus sine y and put the negative on the top. If we knew what sine y was, we could replace it. So sine of y opposite over hypotenuse. So sine y is root 1 minus x squared. That can come in place of sine y, and we have a derivative. It looks very similar to what we had before, except conveniently enough, it's negative, which is great because still we have derivatives of functions starting with c are negative. The derivative of the inverse tan of x. Feel free to try this on your own. To get rid of the inverse tan of x, we will take the tangent of both sides. The tangent undoes the inverse tangent, so you end up with x. You need another explanation of what's going on with that. X starts here. Whoops. Inverse tan takes you back to an angle. Then you calculate the tangent of the angle, and it takes you back to x. So the tangent of the inverse tangent of x is x. We'll draw the diagram for that one. Y would be the angle in the corner, tangent, opposite, over adjacent. Find the missing side using Pythagoras. This time there's a plus sign because we're finding the hypotenuse instead of one of the other two sides. Taking the derivative of tangent, secant squared angle times derivative of angle. Derivative of x is just 1. We'll try that again. Derivative of tangent of angle, secant squared angle times derivative of angle. Our goal is to get dy dx by itself, so we'll divide both sides by secant squared y. And again, because we started with x, we'd like to end with x. So we'd very much like to get rid of secant squared y. We'll look at y. Secant squared is 1 over cosine. Cosine would be 1 over the square root of 1 plus x squared. So secant will be the square root of 1 plus x squared over 1. Secant squared, square root of 1 plus x squared, squared. We'll do that again. Secant, hypotenuse over adjacent, hypotenuse over adjacent, secant squared will square it. That's beautiful because that'll clean out the square root sign. And instead of secant squared, we can just use 1 plus x squared. So again, what happened to the square root sign? We had the square root squared. We did not have that with sine or cosine. So this is the only time we get rid of the square root. So the derivative of the inverse tangent of x is 1 over 1 plus x squared. So here are our 3 rules. Now we're going to find the derivative of some functions. The inverse sine of 5x. Let's look at our rule. We put 1 over the square root of 1 minus whatever we had here squared. So let's check that. 1 over the square root of 1 minus whatever we had squared. Oh, now what's this? This is because we're doing a chain rule. You're taking the derivative with respect to 5x, which gives you this answer, and then we have to take the derivative of 5x. Very much like we did when we found derivatives of sine, cosine, tan. So again, derivative of inverse sine, 1 over square root 1 minus whatever you have here squared times derivative of this. Clean that up a little bit. We'll put the 5 on the top. We'll square the 5 and the x. And that gives us 1 minus 25x squared in the bottom and the square root and 5 on the top. Take a look at that one more time. The 5 went on the top. We squared the 5. We squared the x. The derivative of the inverse cosine of x squared plus 2x plus 1. That's this rule. Negative 1 over the square root of 1 minus whatever you had here squared. So negative 1 over the square root of 1 minus whatever we had here squared. This term again is coming from the chain rule, which says you have to multiply by the derivative of what's inside the bracket. I'll do that again. Inverse cos minus 1 over square root 1 minus whatever was here squared. That's this term right here. Then multiplied by the derivative of whatever's in brackets. Derivative of x squared is 2x. Derivative of 2x is 2. Derivative of 1 is 0, and that's why you don't see anything. In terms of cleaning that up, let's put the 2x and the 2 on top, and we'll put them negative in front. 3 more questions. Feel free at any point in time to put me on pause and try these on your own. Inverse sine of x, of root x, that's this rule. 1 over the square root of 1 minus whatever we had squared. And remember, times derivative of this. And you might be saying, well, why didn't we see that before? The derivative of this was 1 in all these situations, and that's why you never saw that before. So 1 over square root of 1 minus whatever we had squared, and derivative of root x. That's x to the 1/2, so 1/2 x to the negative 1/2. I'll go over that again. 1 over square root 1 minus whatever you started with squared. 1 over square root 1 minus whatever we started with squared. Derivative of x in a square root, that's x to the 1/2, 1/2 x to the minus 1/2. Now, in terms of cleaning that one up, we'll square the root x and just get x. That's much nicer. We'll put the 1 and the 1 together, they're multiplied. We'll put the 2 out front. And these two root signs, we might as well combine them and put the x in with the 1 minus x. And then to get rid of the brackets, we'll get an x minus x squared in the square root sign. What did we do again? First we squared root x, and that became x. We multiplied the 1's together on the top. We put the 2 in front, and that left us a root of 1 minus x and a root of x. So we just put them both under the same root sign, and then multiplied to get rid of the bracket. Inverse tangent of root x. This rule, 1 over 1 plus whatever we started with squared. 1 over 1 plus whatever we started with squared. Times derivative of what's in brackets. That's x to the 1/2, derivative 1/2 x to the minus 1/2. Clean it up again. The root of x squared is just x. And then we can put the 2 out front, combine those 1's, and make it very obvious that these are multiplied together, so we must include those brackets. Let's try this one. The inverse sine of 1 over x squared. If you have not tried one on your own yet, it is really time for you to try this. Let's check. Inverse sine of x. The rule is 1 over square root 1 minus whatever you started with squared. 1 over square root 1 minus whatever you started with squared. Times derivative of this. 1 over x squared would be x to the negative 2. Derivative, negative 2, x to the negative 3. For those who are saying, I don't see an x to the negative 3 anywhere, x to the negative 3 is simply 1 over x cubed. So we'll do that again. 1 over square root 1 minus whatever we started with squared. Derivative of x to the negative 2, negative 2, x to the negative 3, which puts it on the bottom as x cubed. Let's clean this one up a bit. We'll put the negative 2 on front. We'll put the x cubed out here, and we'll square the 1 over x squared. So that gives us a 1 over x to the 4th. Now, we've never liked seeing fractions as part of fractions. If we were to put the x cubed inside the square root sign, we'd have to take x cubed times x cubed, which is x to the 6th. We put x cubed inside the square root sign. If it came out again, we'd get back with what we started. So we now have an x to the 6th, which when we multiply out, we'll clean out that horrible fraction that we had before, and things just look much nicer. So what happened? X to the 6 times 1, and x to the 6 times 1 over x to the 4. There would be 2 more x's on the top than the bottom, and that's why we have x squared. This one, the simplification is really interesting, so you might want to stay with me. The derivative of the inverse cosine of 1 over x. Here's our rule, negative 1, square root 1 minus whatever you started with squared. Minus 1, square root 1 minus whatever we started with squared. Times derivative of 1 over x. We'd write that as x to the negative 1. Derivative would be negative 1, x to the negative 2. Again, I'm not writing the x to the negative 2. I'm simply putting it in the denominator and making it an x squared instead. I'll do that again. -1 square root 1 minus whatever we started with squared. Derivative of 1 over x is the derivative of x to the -1. Derivative would be -1 x to the -2. Cleaning this one up, a -1 times a -1 is a +1. The x squared we'll put in front, and we'll square the 1 over x. So it becomes 1 over x squared. Again, fractions is part of fractions. We don't like that. We'll put the x squared inside the square root. It becomes an x to the 4. So x squared inside the square root becomes x to the 4. We can then multiply that out. So x to the 4 times 1, x to the 4, x to the 4 times 1 over x squared. There'll be 2 more x's in the top than the bottom, so that's x squared. And as far as high school is concerned, this is good. When you get to university, they're going to take it a little bit further. They're going to say x to the 4, x squared. There's a common factor of x squared, so we'll pull that out. And then to clean it out, it'd be really nice if we could pull the x squared out of the root sign. And this is the part I need to explain. You might have been tempted to put down just x. So we need to talk a little bit about the principal square root. This symbol means principal square root. Now, when you see that, principal square root means positive answer only. There's a fair bit of confusion because of the following. In your earlier grades, you would solve y squared equals 4 by taking the square root of both sides, and you'd write this answer down. And you'd say, oh, Miss Duffy, you are wrong. The square root of 4 is plus or minus 2. You were lying about it having to be positive. Not true. You know the graph of the square root of x looks like this. Positive answers only. You do not see a single negative down here. According to this graph, the principal square root of 4 is 2. So what is happening here? Keep in mind, principal square root, most important square root, main one, so positive answer. Here's the step that your teachers never showed you. Principal square root of 4 is positive 2. Principal square root of y squared, the only way to guarantee that y is positive is to put it in absolute value bars. That's why y equals plus or minus 2. Now, this is a little bit confusing, so you have never in your life seen me write this in the board. We tend to do this. What squares to give us 4? Plus or minus 2. What you want to take away from this, when you see principal square root, positive answer only. So when you take the square root of y squared, it has to be the absolute value of y to make sure it's positive. That's all that happened from here to here. Your job today on page 4, 1 to 3, get some practice taking the derivative of inverse trig functions. If you have any questions, contact me at any point in time. I'm happy to help you.